This is a problem on the worksheet that I gave you in class. It's number 3, and it's a good problem to know how to do for the test. Basically, you have a 25 kilogram box on a 30-degree incline. The coefficient of friction is 0.25. So we know there's friction on here. First thing we're going to do is draw a free body diagram. We'll already have the force of gravity, or the weight, on here, and that's going to be 250 newtons. That's mg, 25 kilograms times 10 meters per second squared gives me 250. Okay, the next part is I'm going to divide the force of gravity into two parts. There's a part that points down this way. Now this is perpendicular to that surface, and that's what pulls it to the surface, and then there's a part that pulls it downhill. That's going to be perpendicular to this one. And we already know that 30 degrees is right here, if I could fit that in there. 30 degrees, because it's a similar triangle, so this angle here is the same as that angle there. Alright, and we know that there is a normal force pointing up this way, F sub n, normal force. And then we know there is a force of friction pointing up this way. We don't know what that force is, we know what the coefficient is, not the force. So, the next part is to find the magnitude of the normal force. Well, we're going to find that by finding the red part of gravity, alright? And that's going to be 250. It's going to be mg cosine of the angle, where this here, this red part, is adjacent to the 30 degrees. So it's going to be the hypotenuse, which is 250 newtons. That's the force of gravity, or the weight, times cosine of 30 degrees, and that's going to give me 217 newtons when I round it off. Let me check that to be sure. Yeah, 217. So I know this equals 217 newtons. Alright, so we've got A, we've got B. Find the magnitude of the frictional force. Well, to find that, friction is going to equal mu times the normal force, right? The fun equation. So, F equals 0.25. That's the coefficient of friction that was given in the original problem up here, times the normal force, which is 217 newtons. And when I do that, I get 54. So this is going to equal 54 newtons. Well, how much gravity, how much of the weight or the force of gravity is pulling this downhill? Well, that's this part down here of the triangle. That is opposite the 30-degree angle, which is sine. So that part is, I'll just put it right here, is going to be 250 newtons times sine of 30 degrees. That's going to be 125 newtons. So, part of gravity pulling it downhill is 125 newtons. Now the next part says find the acceleration of the box. Let me ask you this. In this going back and forth here, 125 newtons is bigger than 54. So what I'm going to do is to find the acceleration of the box is I'm going to go down here and I'm going to say the sum of the forces equals the net force, which equals ma. So the sum of the forces, well, that's the one, and I always make friction negative, so 125 newtons minus 54 newtons, that's friction, equals, I don't have a net force, but I do have, actually I do have a net force. I can subtract those two and get net force, but I don't have a number because I haven't done this yet. I haven't done 125 minus 54. That's 25 kilograms times A That's what I'm looking for. So if I do 125 minus 54, I get 71 newtons. So 71 newtons equals 25 kilograms times A. A is going to equal 71 divided by 25. And that's going to give me 2.84. 2.8 meters per second squared. That is the answer if you look on the answer sheet. That is an answer. That's the answer. That's it. That's how you do number 3 on the worksheet.